Welcome to another episode of Environmental Digest. Today, we are going to talk about a colossal source of clean energy right under our feet, geothermal energy.
To really get a sense of the incredible power we're dealing with here, let's just start with a quick comparison. On one side, you've got our home, planet Earth, and on the other, the blistering surface of the sun. Both of them are obviously immense sources of heat.
But here's the wild part. One of these heat sources is, millions and millions of miles away. The other one? It's literally right under our feet. And get this, deep inside our own planet, the temperatures are almost identical to the sun's surface.
So how on Earth do we actually tap into this planetary furnace? Well, in this explainer, we're going to start with the source itself, Earth's inner fire. Then we'll look at how we've gone from just enjoying hot springs to generating real power. We'll also explore why geothermal is called an always-on renewable. But we also have to look at the risks hiding under the surface. And finally, we'll take a peek into the future of geothermal.
All right, let's dive right in with the source itself, the Earth's inner fire. Our planet has been radiating heat from its core for about 4.5 billion years. I mean, it's a truly ancient power source, literally left over from when our solar system was first forming. At the very center of our planet, the temperatures reach a staggering 6,000 degrees Celsius. That's about 10,800 degrees Fahrenheit. It's an almost unimaginable amount of thermal energy.
And this brings us right back to that first comparison we made. You don't need to travel 93 million miles to the sun to find that kind of mind-blowing heat. Nope, you just need to go down about 4,000 miles.
And that, right there, is geothermal energy in a nutshell. As you can see, the name itself kinda tells the whole story, coming from the Greek words for earth and heat. It's simply the raw thermal power of our own planet, just waiting for us to use it.
But tapping into this incredible heat source is not a new idea at all. Humans have been using the Earth's warmth for a very, very long time, way before we ever dreamed of generating electricity with it. So it all started with the obvious, right? Using natural hot springs for bathing and cooking. But as our technology got better, so did our ambitions. By the 1890s, Boise, Idaho was heating entire city blocks with geothermal water. Then, the 1940s brought heat pumps for individual homes, and by 1960, we were generating electricity on a massive commercial scale.
And here's a look at that very first commercial plant in the US. It's known as the Geysers in California. Incredibly, it is still the world's largest geothermal field today, which is a huge testament to just how durable this energy source really is.
So, geothermal has a really rich history, but it's the future potential that's truly exciting. Let's dig into why this always-on renewable could be a total powerhouse for modern energy. The Earth is just constantly radiating a mind-boggling amount of heat. We're talking about 44.2 terawatts. And just so you know, 1 terawatt is a trillion watts. It's just this enormous, continuous flow of energy from a planet's core right up to the surface. To put that number into perspective, that constant flow of heat is more than double the energy the entire world uses from all sources combined. The power is there, it's just waiting for us to tap into it.
And this isn't just limited to a few volcanic hotspots either. This heat map of the United States shows these vast underground resources that are accessible right now with the drilling technology we already have. See those red and orange areas? They highlight immense energy potential just sitting a few miles beneath the surface.
So you're probably wondering, if the potential is so huge, why isn't it everywhere? Well, compared to solar and wind, geothermal has one key advantage and one major disadvantage. Solar and wind are intermittent, right? The sun isn't always shining, the wind isn't always blowing. But the Earth's heat is always on. It provides stable, reliable power 24/7. We call this baseload power. The catch? You have to drill to find it, and that involves a much higher upfront risk and cost.
And believe me, that upfront cost is just the beginning. Tapping into this incredible power source definitely comes with its own unique set of challenges and risks.
So yeah, what's the catch? If all this energy is just sitting there right beneath us, why aren't we using more of it? Well, the answer really lies in the complexities of drilling deep, deep into the Earth's crust.
For starters, drilling into the crust can, sometimes, trigger minor earthquakes. Then there's the issue of subsidence, where if you pull out large amounts of underground fluid, the land above can actually sink. The steam itself can bring up some polluting gases and minerals to the surface. And on top of all that, the initial cost of just exploring and drilling is incredibly high.
For most of our history, we've relied on what's called conventional geothermal. You can think of it like picking the low-hanging fruit. We look for places like Iceland or the geysers in California, where nature has already done the hard work and created these huge underground reservoirs of hot water or steam that are pretty easy to get to.
But just relying on those natural reservoirs is, well, geographically limiting. And that's where the next generation of tech comes in: enhanced geothermal systems, or EGS. With EGS, instead of trying to find a natural reservoir, we actually create one. We drill down to hot, dry rock, carefully create a network of tiny fractures, and then circulate water through them to generate steam.
And this is where the future of geothermal gets really, really exciting. EGS technology could be the key that unlocks the Earth's heat almost anywhere in the world.
So here's basically how it works. An injection well sends cool water deep underground. That water then flows through that network of fractures we made in the hot rock, and it heats up super fast. Then a production well brings that superheated water, or steam, back up to the surface to power a turbine. It's essentially a man-made geothermal power plant created right where we need it.
And this really brings us to our final question. We spend so much time looking up at the sun, at the wind, for our clean energy. But what if the most powerful, the most consistent, and the most abundant source of all has been right here, just a few miles beneath our feet for billions of years?